Hey guys, here's a video for 11-3, probability of multiple events. This is a two-part video, so this is part one of it. The aim for today is to find the probability, right? Remember that symbol from yesterday of A and B, and the probability of A or B. A and B being two different events. So to start us off, let's think about what the difference between the two words dependent and independent are, right? So to be independent means to be completely self-sufficient, to not need anybody else, to be not reliant on something else. Whereas dependent means that you are relying on something else. You are affected by other things outside of yourself. So the same concepts are going to apply to those words when we're looking at them as probabilities. So we're going to be looking at dependent versus independent events. Independent events being events that are not affected by other events. For instance, flipping a coin. If you flipped a coin 100 times, flipping heads on the first time does not affect whether or not you will get heads on the second time. It's the same chance every time. So those would be considered independent events. Whereas dependent events are when the occurrence or outcome of one event affects how the second event can occur. For instance, if you have marbles in a bag, right? If you pull a marble out and do not replace it, you are changing the number of marbles in the bag for the future. So that means the second marble you pull out of the bag is going to be dependent on what you pull out of the bag the first time, right? If you replace the marble, then it goes back to being independent events. But as soon as you take it out and leave it out, they are dependent events. So we need to be able to recognize these in the context of a question. So we're looking at page 691, number 9 and number 11. They want to know, are these dependent events or independent events? So number 9 says a month is selected at random. Then a number from 1 to 30 is selected at random. So the question is, does selecting a month affect the number that you choose? And the answer is no, right? Selecting the month does not affect choosing a number at random from 1 to 30. So these would be independent events. Number 11. A letter of the alphabet is selected at random. One of the remaining letters is selected at random. So the question is, does the second event depend on what happens in the first event? And the answer is yes, right? Because if you pull a letter from the alphabet, let's just say you pick A. On the second round, you no longer have A to choose from. You only have from B to Z. So what you choose in the second round is dependent upon what happens in the first round. So these would be considered dependent events. Okay. So now we have to make some calculations with independent and dependent events. And these calculations are finding the probability of two events. So the formula that I have up on the screen is if A and B are independent, so this formula is applying for independent events, then the probability of A and B equals the probability of just A times, remember that's the multiplication symbol, the probability of just B. So I want you to start associating the word and the word multiply. Okay, because when we're looking at probability, if we're talking about and, there's going to be some sort of multiplication involved. So if we're looking at page 691, number 14, it says Q and R are independent events. Find the probability of Q and R. Okay, so if we follow the formula that we see above, the probability of Q and R is equal to the probability of Q times the probability of R. Well, we have those probabilities up on the screen. The probability of Q is 12 over 17. The probability of R is 3 over 8. So we're going to want to multiply those two together to get our final answer. Now, because we're working with fractions, you can do some cancellations if necessary, or if possible. So 4 goes into 8 2 times, 4 3 times. This gives me 9 over 34. So the probability of Q and R is 9 over 34. Okay, so now let's apply this to some real-world context. So we're looking at page 689, problem number 2. It says, at a picnic, there are 10 diet drinks and 5 regular drinks. There are also 8 bags of fat-free chips and 12 bags of regular chips. If you grab a drink and a bag of chips without looking, what is the probability that you get a diet drink and a fat-free chips? Okay, so we have to think about what my 2 events are going to be. The 2 events are pulling a drink and pulling a bag of chips, right? The question is are those dependent events or independent events? Does pulling a drink affect pulling a bag of chips? And the answer is no. Those 2 things are not affecting one another. We're assuming the drinks are in the cooler and the bag of chips are on the table, okay? So these are going to be independent events. Which means that if this is an AND equation, which it is because we see the word AND, we can use this formula above. So what we're looking for, the probability that you get a diet drink, and fat-free chips. Okay, so we're looking for the probability of diet and fat-free. So remember, AND means multiply, so we want the probability of diet times the probability of fat-free. So let's take a look. So we're looking at the sodas. There are 10 diet drinks and 5 regular drinks for a total of 15 drinks. How many of those are diet? 10. So the probability of pulling a diet drink will be 10 out of 15. We're going to do the same thing with the chips. There are 8 bags of fat-free chips and 12 bags of regular chips for a total of 20 drinks in my denominator. We're looking at only fat-free, so my numerator is going to be 8 out of 20. So we're multiplying 10 over 15 by 8 over 20. And we can make some cancellations. So 10, 2, and we get 8 over 30. We know we need to reduce our fractions to lowest terms. So that's going to be 4 over 15 as my probability. Okay, so the probability of pulling a diet and a fat-free is 4 over 15. So now what is the probability that you get a regular drink and a regular chips? Okay, so again, we're looking at AND here. So we want probability of regular and regular. And let's regular drink, and let's call this regular chips. So again, since it's AND, we're multiplying. What are we multiplying? The probability of a regular drink and the probability of regular chips. Okay? So we're going back up here to the question. What's the probability of pulling a regular drink? Well, again, there's 15 total. 5 of them are regular. So my probability here is 5 over 15. And for the chips, there are 12 bags of regular chips out of a total of 20. So my probability of pulling regular chips is 12 over 20. Now I multiply. I'm going to cancel here with 5s. I'm going to cancel here with 3s. 4 over 5, so that gives me 4 over 20, which I can now reduce to 1/5. So the probability of pulling a regular drink and a regular chips is 1/5. Okay. So I'm going to ask that you pause the video and attempt this question. It's asking you if you have a playlist with 4 pop songs, 1 hip-hop song, and 2 country songs, and every day you put your playlist on shuffle and play 1 song at random on your way to school. What is the probability that you listen to a country song 2 days in a row? So if you need a little hint here, hopefully you've pressed pause, but if you need a little hint here, if you're listening to a country song 2 days in a row, right, Listening to a country song the day before will not affect if you listen to that same country song the next day because it's selected at random. Okay, so we're looking for the probability of country and country, and they are independent events. Oops. Okay. So here's the answer to that. First, we need to find out what are the total number of songs on the playlist. 4 plus 1 plus 2 is 7 total songs. So remember, if we're looking for a probability of country and country, we're going to be multiplying the probability of listening to a country song times the probability of listening to a country song. So there are 2 country songs of the 7 total on the playlist. So the probability of listening to a country song is 2 over 7. We multiply that to itself to get 4 over 49. And that will